So this is number 4 from the homework examples. You can't see it because it's stapled there. It's number 3 from the actual homework. We already did this part right here. Now we're going to talk about the prediction part to answer this part below here. To start off with, from our calculator, I'm just going to pull this back up here. This is the value of R from our calculator, negative 0.955 roughly. Okay. So what I have to do is I have to see if it's correlated to go any further. So I'm going to compare this with the critical value. The critical value is not actually provided for this example, but you can look at one of the previous homework examples, or you can look at the formula card, which I'll provide. N is 5 because we have 5 values, 1, 2, 3, 4, 5. And I picked the 0.05 significance level. Usually they tell you, they just didn't tell you with this one for some reason. So if I look under here, 5, you can see it here. Okay, so 5.05 gives me 0.878. That's my critical value. That's what I wrote right here. Okay, so I want to decide if they're correlated or not. So going back to what we talked about in the last section here. Oops, sorry about that. Put my hand on it. Okay. If the value of R is bigger than the critical value, I should say if the absolute value of R is bigger than the critical value, they're going to say there is correlation, there is a linear correlation. So in this case, the value of R is bigger than the critical value, so we're going to say there is a linear correlation. So what that means is these two things, which it doesn't seem like they would be, according to this sample data, they are actually linearly correlated. So now we're going to talk about prediction. Okay, so if they are correlated, then basically you could plug in a value for x into this equation, and you should be able to find y if they are correlated. Okay, so I'm going to go to another handout that I'm going to give you. I'm going to put online. This is the one you want to use for prediction. So if they are correlated, you're going to go ahead and plug in the value for x into your equation, your linear equation, and solve. If they're not correlated, I'll do one of those in another example. Then you're going to use the average of the y as the second variable. Okay, so this one relates to this one. Okay, so this is my equation right here. And then we move it up. Okay. What I have to do is I have to plug in for x, and they said x, the number of lemon imports is 500. So I have to basically plug that in. Okay, so let me show you my calculator. When I plug that in my calculator, that's a 500 right there. It's kind of hard to see. And let me just show you again. The 500 comes from right here, just so you know. They have to give you that. If I hit enter, it gives me about 15.048. So that's what they get the answer right here. Oops. Okay. And then let's go ahead and answer the other question. Is this prediction worthwhile? Common sense suggests that there doesn't seem to be much of a relationship between the two variables. So it really doesn't make sense that lemon imports is somehow linearly related to crash fatality rates. So it's kind of a unusual one. We actually looked at a very small sample here. You know, I bet if you looked at a bigger sample, we wouldn't see the correlation between the two.